Hi everyone, we're starting our next section, exercise 10H, and what we're going to be doing is we're going to be doing some problem solving with the sine and cosine rules. So all the rules that we've used or that we've looked at so far, we're going to be applying them now to real world situations. Alright, so let's take a look at the first example. It says that ship A and ship B start their journey at the same location. Ship A travels 36 kilometers on a bearing of 47 degrees, and ship B travels 56 kilometers on a bearing of 119 degrees. Find the distance and the bearing of ship B from ship A. So the first thing we definitely want to do is we definitely want to draw out the problem. So what we're going to do is, with respect to north, since we're starting at the same place, with respect to north, so here is our north line, ship A is going to move 47 degrees, and moving 47 degrees for 36 kilometers, and that's where our ship A is going to be, at 47 degrees. Now, our next part of the question says that ship B travels 56 kilometers on a bearing of 119. Well, it's still from the same starting point, so 119 degrees is approximately this much, and 119 degrees will go for 56 kilometers. So the line will be slightly longer than the 36 kilometer line. And this is where ship B will be found. And it will be at 119 degrees. Alright, so what we're looking for is we're basically looking for now the length of AB, or the distance between ship A and ship B. And on top of that, we are also looking at finding the bearing from A towards B. So with respect to north, starting at A, going towards B. So this is our theta that we're going to be looking for. Okay, this will be our bearing up here. So we're just getting our problem in order. Alright, so before we start with doing anything else, we do need to make sure that this is not a 90-degree triangle, or maybe it is. But just to make sure, what we're going to do is we're going to start calculating several things. So the first thing I want to start calculating is to see whether it is 90 or not. And this angle here where it says 119, inside the triangle, it looks like it could possibly be a 90-degree angle, but we're not sure. And the way to calculate that would be to simply just say, well, if I take the 119-degree angle and I subtract the smaller 47-degree angle, if it were a 90-degree triangle or a right-angle triangle, it would equal 90. But the problem is that it is not. So we'll have 119 minus 47, which gives us an angle of 72 degrees. So we know, therefore, that inside here, so I'm just going to do this inside here, I'm just going to mark that off, this is going to be 72 degrees. Now, because we know that that's 72 degrees now, we have an angle that is inside the triangle, which is 72 degrees. Alright, so in knowing that, I think that we can look to see what information we've got with regards to figuring out what the length of AB is, or the distance from ship A to ship B. Well, we have a length here. One of the sides is 36 kilometers, or 36 of this of the triangle. I have another length here that's 56, and we also have the angle that's in between them, which is 72 degrees. So the only thing that we can use at this point to solve here would be the cosine rule. And what the cosine rule basically tells us is that we're going to say that AB squared, so the length of AB, the distance between the two ships, is going to be equal to one side squared, 36 kilometers squared, plus the other side squared, which is 56 kilometers squared, and that's going to be minus 2 times the product of the two lengths of the sides, which will then get multiplied by the cosine of the angle between them, which is 72 degrees. Now, in solving that, I think I am going to do this with you here on the calculator so that we can all see what's going on. Whoops. So that we can all see what's going on here. So what we're going to do is we're going to have, maybe I should bring it over to this side. So we'll say, that 36 squared plus 56 squared minus 2 times 36 times 56 times the cosine of 70. I'm not sure why that's not going. The cosine of 72 is equal to, press enter, and we get 3,186.04, 3186.04, and now I have to take the square root of that, so it becomes 3186.04, and I'll put that on my calculator. I'll do second function, square root, second function, my previous answer, and I get 56.4. So I know that my length here is going to be 56.4 kilometers rather. Okay, so we have that. We have figured the distance, therefore we can say therefore the distance between the two ships is 56.4 kilometers. Okay, so that's part A of the problem. Part B of the problem wants us to find angle theta, which is the bearing from A going towards B. So if we're standing at A, in what direction are we going to have to move in a clockwise direction that will take us to point B, or take us to ship B? So what we do is, well, we know that one angle is 72 degrees. I know that this angle up here is 47 degrees. Now, because these are both north lines, so I'm going to put these in black now. Because these are both north lines, this is a north line, and this is a north line, and because there's the transversal crossing through, I technically can figure out now what this angle internally is here. Now, why would I want to do that? So I would want to do that simply for one reason, because if I know that this angle is 47 degrees, then this angle has to be 180 minus 47, which makes it 133. So using the fact that I've got two parallel lines, and I know that this angle is 47, then this angle has to be 133. And if I know that that's 133, if I figure out what angle alpha is inside the triangle, then I can add 133 plus that angle alpha, and then I could subtract them from 360 degrees, because the only angle left over that I'm looking for is my bearing, which is theta. Okay, so what I'll do is, I know that one angle is 133 degrees there. I'm going to now look for alpha, and I can use, most probably, let's see what I've got. I've got 72 degrees, I have its opposite side, and I have alpha, which is what I'm looking for, and its opposite side, so that I can use the sine rule here and say the sine of 72 degrees over 56.4 has to equal the sine of alpha divided by 56. And when I cross multiply here, I got 56 times the sine of 72 all divided by 56.4 equals sine of alpha. Now I bring the sine over to the other side, so it becomes sine inverse of 56 sine of 72 degrees over 56.4, which is equal to alpha. So if it's equal to alpha, and therefore I just place this in my calculator. We'll just do this one more time. So I'll do second function sine of, and I'll say 56 times the sine of 72, close the bracket, and then divided by 56.4, close the bracket, enter. And I get 70.7 degrees is equal to alpha. Now my final step here is, because this is now 70.7, all I have to do now is say, therefore, the bearing is going to be 360 degrees minus the sum of the two internal, times the sum, plus the sum of 70.7 plus 133. So that I end up getting, therefore, I will do 360 minus 70.7 and then minus 133. Enter, and I get 156.3. So my bearing will be 156.3 degrees. So the final answer is, therefore, AB, length AB is equal to 56.4 kilometers with a bearing of 156.3 degrees. Okay. The next example is a question for a surveyor that wants to find the distance from D across a river to A, but this line of sight is being blocked by the house, so he decides to take some other measurements as they are shown here on the diagram. And what we're trying to find is the distance between A and D. Now, given the information that we have here, we're basing part of it on what's going on the other side of the triangle. So if I were to figure out what the length of AC is, because I think I want to figure out what the length of AC is. So if I do the length of AC, of segment AC, I can find that by simply saying, well, I know that 67 degrees plus 88 degrees subtracted from 180 will give me this angle here. So if I do 180 minus 67 plus 88, so it's 180 minus 67 minus 88, and that tells me that the angle in here is 25 degrees. So I can figure out what AC is by using the sine rule. And so I can say sine of 25 over 32 is going to have to equal the sine of 88 over AC. Now I rearrange everything so that I end up getting AC, which will be equal to 32 times the sine of 88 degrees, and that'll be divided by the sine of 25. So that AC will equal, so again, using our calculator, we'll say 32 times the sine of 88, close the bracket, enter, divided by the sine of 25. And close bracket, enter, and we get 75.7. So AC is equal to 75.7 meters. So if this is 75.7 meters, I can now use the cosine rule, because the only piece of information I've got here are the two sides and the included angle. So to find AD, find the length of AD, then what I'll do is I'll say, well, AD squared has to equal 37 squared, one side squared, plus the other side squared, 75.7 squared, minus 2 times 37 times 75.7, and then times the cosine of the angle between them. Remember, it's two sides and the included angle to be able to use the cosine rule. And it'll be the cosine of 58 degrees. The cosine of 58 degrees, which I don't think you're seeing this on your screen because I moved everything over too much. So let me just adjust that so you can see everything on your screen as such. There. Alright, and so now I'm just going to place all of this into my calculator so that I will have, again, so you have one more opportunity to see the calculations being done. I will do 37 squared plus 75.7 squared minus 2 times 37 times 75.7 times the cos of 58, enter, whoops. Oh, I forgot the square. I didn't get 75.7 squared there. Let's try it again. 37 squared plus 75.7 squared, there we go, minus 2 times 37 times 75.7 times the cosine of 58, enter. It's 4,130, and when I take the square root of that, I get 64.3. So that AD squared is 4,130 point something, and AD, when you take the square root, we said that it was 64.3 meters. Okay, and that's done. So we have found the length of the distance between A and B. All right, the next question I am going to leave for class, and let's see the next one after that, and then we are done for today. All right, so we've got a person that is sightseeing from the top of a building. So a person is sightseeing from the top of a building, and they can see a car below at an angle depression of 30 degrees. So the person is up here, and it's a 30-degree depression, and here's the car. So here's our car. I know it's a beauty. Okay, there's our car, and now it's at 30 degrees, the angle of depression. All right, now the car then moves directly, so the car is going to be moving directly away from the observer to the next intersection, which is at a distance of 200 meters away. So we know that this distance here is 200 meters, and this is where the car is now. Okay, and this is 200 meters. Okay, now its angle of depression now is 25 degrees. So the question being asked is, how tall is the building? All right, so how are we going to figure out how tall the building is? Well, what we can do is simply this. If I call this A, and I call this B, and I call that C, and I call that D, okay, what I can do is I can find the length of AB. So let's find the length of AB. But before I can find the length of AB, I've got to find the measure of the angle that is in between here. So this blue here is 30, and then this angle here is 25. So we're going all the way down here like this. This is 25. Okay, so that means that the angle that's left over in here, which I'm going to call theta, is really going to be 30 minus 25, which makes it 5 degrees. So that, let's see what other piece of information we have here. We know that that's 5 degrees. We know that that's 200. What else do we have? Okay, so since this angle here is 25 degrees, and because these are parallel lines, okay, I'm putting arrows on the parallel lines, I have a Z pattern here. So if this is 25 degrees, then this angle inside here, because of a Z pattern, also has to be 25 degrees. So now I tend to have two angles, and I have a side, which means that I can most probably find the length of AB. Okay, so let's find the length of AB, and finding the length of AB means that I'll say the sine of 5 degrees over 200 has to equal the sine of 25 degrees over, let's say, the length of AB. So that AB will equal 200 sine of 25 divided by the sine of 5 degrees. And when I work that out, I will get 200 times the sine of 25, and I will divide that by the sine of 5 degrees, and I end up with, oops, I just messed that up, so let me try it again. So I have 200 times the sine of 25. I didn't put in all the numbers. Enter. And then it gets divided by the sine of 5. And that gives me a value of 969.8. So that equals 969.8. So I know that this is 969.8, the length of AB. Now, all I need to do is I need to find the height. The height is right here. This is the height. Now, in doing the height now, I can, let's see what we can do. I now know also the measure of the angle. If that's 30 degrees there, then this angle in here has to also be 30 degrees because it's another Z pattern, that and that angle. These are parallel lines. So that I can say opposite over hypotenuse, which is sine. So I'll do the sine of 30 degrees is equal to the height over 969.8, and so that I'll get h is equal to 969.8 times the sine of 30 degrees. So when I work that out, I will get, working it out, I will get 969.8 times the sine of 30, close the parentheses, enter, and it'll go to the height of 484, approximately 484 meters. And that's the end of that problem. All right, I'm done, and your homework is going to be section 10H, questions 4 through to 10. All right, see you next time.